In this lesson, we're talking about mixing solutions together, two solutions that contain the same chemical species. Here's a good example here. Perhaps this is some copper chloride that is a nice blue color, and you can see in one solution the concentration is a little bit less, it's a lighter blue, and in the second solution it's a more concentrated solution, it's a nice dark blue. When we mix them together, of course, we're going to get a new concentration. What's happened is that all the moles from our solution number 1 are now added to all the moles from solution number 2, and they're combined in our new mixture. The new volume of our resulting solution or resulting mixture is the sum of the two volumes added together. So our volume number 1 and our volume number 2 put together. So in this new mixture, we have the sum of the moles and the sum of the volume. So one method to find the concentration of our mixture is actually just to figure out how many moles were in each solution and add them together, and then add up the volumes as long as your volumes are in liters. That our equation for molarity, C is equal to N over V, will work to solve this problem. There are a couple of extra steps involved with that type of a method, so there's another fast way to solve this question, and it's just using our simple dilution calculation, C1V1 equals C2V2. If we think about each one of our solutions as undergoing a single separate dilution, so that, for example, when we add the contents of flask number 2 to flask number 1 to get our mixture, well then flask number 1 has undergone a dilution, and I can calculate the new concentration, C2. I can also do the same thing in a separate dilution calculation for my second flasks. I can figure out what's the new concentration once I've added the first flask to the second flask, and I would get another C2. So I would have C2 for my first dilution and C2 for my second dilution, and added together those two concentrations will give me my total concentration in the resulting mixture. Now of course this is only true when we're calculating the concentrations of the same chemical species. If my two flasks contain different chemicals, I could still perform two separate dilution calculations, but I wouldn't add those concentrations together at the end if the chemicals weren't the same. Okay, let's go ahead and try the example. Example number 1, I've got what is the concentration of calcium sulfate solution produced by mixing 145 mils of 0.35 molar calcium sulfate. So right away, let's label this one solution number 1. Okay, and we're mixing it with 165 mils of 0.18 molar calcium sulfate. Let's call this solution number 2. Now notice that they both contain the same chemical, calcium sulfate, so I know that in the resulting mixture I am going to be able to add the two concentrations, final concentrations, together. So one method of solving this problem is to treat each of these solutions as a separate dilution. So I'm going to perform two dilution calculations, one for solution number 1 and one for solution number 2. I'm going to find the C2 for each, and then I'm going to add them together at the end. If you're a visual learner, it's a great idea to draw yourself a little diagram of what's going on here as a way of unpacking the question and organizing C1 and V1 for yourself. Okay, I'm going to go ahead and just solve this as cleanly and neatly as I can. And the first thing that I'm going to do is I'm going to find my V2, because it's going to be the same for both of these. Remember that our final volume here is going to be the two volumes added together, because we're putting both solutions together. So I'm going to have 145 mils from my first solution added to 165 mils from my second solution. So that gives me 310.0, let's keep our decimal places, milliliters. Okay, that just saves me time. I can do it once right at the beginning. There's my total volume. Okay, so my first step here is I am going to go ahead and I'm going to perform dilution number 1. So dilution number 1 is where I consider the 145 mils of 0.35 molar calcium sulfate being diluted to a total of 310 mils. So I'm going to calculate my C2. Okay, remember that C1V1 equals C2V2. So C2 is equal to C1V1 over V2. We should be getting good at this by now. And I'm going to put in my values. So C1 was 0.350 moles per liter, multiplied by V1, which is the volume for the first solution, 145.0 milliliters. I'm okay to use milliliters here because I'm doing a dilution calculation, and as long as my V2 is also in milliliters, which it is, then they will cancel. And my final volume I determined is 310 mils. Okay, so we're going to go ahead and do the math here. So my answer is going to come out to be 0.1637. Let's keep as many decimal places as we can manage here. So I'm going to go ahead and keep about 6 decimal places. My units are moles per liter. My milliliters canceled and I was left with moles per liter. Now I don't want to go ahead and round this answer off right now to have 3 sig figs. That would be a mistake because if I round, I still have a couple more steps after this. If I start rounding all my answers for each step, my final answer is going to be incorrect. I'm going to have a rounding error, which causes my number to be too big or too small. So what I'm going to do instead is I'm going to underline how many sig figs I'm allowed to have so that I can keep track of sig figs without actually losing any of my numbers. So we're allowed to have 3 sig figs here. This was a multiplication division question, and the number 0.350 has 3 sig figs. That's the least number. So I'm going to go ahead and round this, or pardon me, I'm going to underline the first 3 digits. There's 3 sig figs, but I'm not going to round that to 0.164. Okay, I'm going to leave it like that. Great. Let's do dilution number 2. Okay, so now I'm going to dilute the second solution. So C2 is equal to C1 V1 divided by V2. And I'm being careful to put in the right numbers. So my C1 here was 0.180 moles per liter. And my initial volume for my second solution is 165 milliliters, keeping my units and all my digits in my calculation. And my final volume was 310 mils. Okay, my units of milliliters cancel. My answer is going to be in moles per liter, and my answer here comes out to be 0.095806. Again, I'm leaving enough decimal places that I'm not rounding my answer too early, and I'll go ahead and underline my sig figs. Now again, here I'm allowed 3 sig figs, so I'll start counting at the 9, 1, 2, 3, and I'll just underline them, but I won't round it off there. Alright, now for my C total, my final concentration, I am going to add the concentration from my first dilution, so we'll call that number 1, to the other final concentration that I calculated for my second dilution, number 2. Okay, let's go ahead and do this. Okay, so I have my number 0.163710 moles per liter. Let's underline the first 3 digits because those were my 3 sig figs. Okay, plus my second calculated concentration, 0.095806 moles per liter. And I had 3 sig figs from there. Now notice all of a sudden I am doing an addition. So the addition subtraction sig fig rule applies here. I have to round my answer to the least number of decimal places. So let's go ahead and do the math. It's going to come out to be equal to 0.2591516. Okay, if we leave some of the digits that I'm seeing on my calculator when I add those together. And looking at decimal places, in the very first value there were 3 decimal places that I was allowed, okay, because I underlined my sig figs, and that's a total of 3 decimal places. And on the other side I had 3 sig figs, but notice that that's actually 4 decimal places that I'm allowed there, because all of those digits all the way up into the 8 are significant. Now the 0 is not significant, but all the way up into the 8 is significant, which means that there are 3 sig figs here but 4 decimal places. Okay, so my answer needs to be rounded to the least number of decimal places, which is going to be 3 decimal places. Okay, because I'm limited to the least precise number. So 3 decimal places puts me right here. Okay, at the 9, I look to the number after the 9. It is 5. It's 5 or greater is enough to round that 9 up. So my answer is going to come out to be that the concentration is equal to 0.260. I need to have 3 decimal places here. Okay, so I'm going to round that up to be a 60, and my units are moles per liter. This number has 3 significant figures in it. But I followed my sig fig rules all the way along, so I can be confident that my answer has the right number of sig figs. And there's my final answer. That's the concentration, going all the way back here, of calcium sulfate in my mixture. I know I have recorded or I have offered an alternate way to solve these problems. You're welcome to choose either one. You can look at the course. You can go back and you can have a look at the alternate method and see which one works for you better. But since we've been doing dilution calculations all the way along in the last lesson, most students prefer to continue with doing a dilution calculation, 2 dilution calculations, to solve questions like this where we're just mixing solutions together. But whichever one works for you is the one you should choose. Best of luck!